Geology Project, Copper, by Group 3, Mia Gomez, C.R. Chavez, Luke Daly, Abby Hooker, Joa Pinkston, and Meta Schlinke. Defining copper. A quick description about copper is that it is a chemical element of group 11 in the periodic table. Copper is a reddish brown color, but pure copper before oxidation is normally pink. Copper is ductile and malleable, which means it is flexible. Copper is an excellent conductor of electricity and heat. And copper is chemically made up of natural ores, such as copper sulfide ore or a copper oxide ore. These ores are mined, crushed, and processed just to make up copper. And here's a quick picture just to show you what copper looks like.
When looking for the formation of copper, it's important to know where it's found. Copper in its elemental form is found naturally in the Earth's crust. Its formation is deeply rooted in geologic processes that have shaped our planet over thousands of years. The story of copper's formation begins with the Earth's mantle, where high temperatures and pressures facilitated the formation of metallic elements. One of the main primary ways in which copper is formed is through hydrothermal processes. Deep within our Earth's crust, hot water containing dissolved minerals circulates throughout and fractures the rock. These mineral-rich solutions can sometimes contain copper ions delivered from weathering of copper-contained minerals in the surrounding rocks. As the hot water rises towards the surface, it encounters cooler temperatures, causing the copper ions to precipitate out of the solution and deposit into the walls of the rock fractures. Over time, these deposits accumulate and form veins of copper, which can vary in size and richness depending on the conditions and the concentration of copper in the original mineral solutions. The formation of copper deposits is also closely tied to volcanoes. Volcano eruptions can bring copper-rich magma from the deep earth crust, and when it's erupted, it cools and solidifies itself, forming indigenous rocks known as porphyry copper deposits. These deposits can be massive in scale and represent some of the largest sources of copper found worldwide. Once copper can be formed, it undergoes a series of geological processes, including weathering, erosion, sedimentation, which can all transport the ore to different locations and consecrate it into different deposits. And it's a very useful tool.
Copper originated from the island of Cyprus in the Mediterranean and numerous other sites in the Middle East. Because copper reacts with other substances, it can be formed in a variety of ways in the Earth's crust. Copper is also found in various minerals and ores around the world. Ores are naturally occurring minerals containing a valuable metal for which it is mined and worked. Copper minerals often occur in deposits with igneous, sedimentary, and metamorphic rocks. Copper deposits are a geological formation or occurrence where significant concentrations of copper minerals are found. These deposits are the primary sources from which copper is extracted for commercial and industrial purposes. One example of a geological location it can be found is where there is volcanic and magmatic activity. As magma cools and crystallizes underground, it can form copper-bearing minerals. Additionally, some copper deposits form through the weathering, erosion, and sedimentation of pre-existing copper-bearing rocks. Sedimentary copper deposits can occur in sedimentary basins, along with other sedimentary rocks. These deposits often result from the concentration of copper minerals through chemical and physical weathering processes. Copper deposits can also form through the metamorphism of pre-existing rocks containing copper minerals. The heat and pressure associated with metamorphic processes can cause the recrystallization and concentration of copper minerals. Importance of copper. Copper is an excellent conductor of electricity. This property is crucial in various electrical applications, including wiring, motors, transformers, and electronic devices. Copper has high thermal conductivity, making it valuable in applications where heat dissipation is essential, such as in heat exchangers and cooking utensils. Copper is a durable metal with excellent corrosion resistance This makes it suitable for plumbing systems, roofing, and outdoor applications. Copper possesses natural microbial properties which inhibit the growth of bacteria, viruses, and fungi. This property is increasingly recognized in healthcare settings where copper surfaces can help reduce the spread of infections. Copper is commonly alloyed with other metals to improve its properties for specific applications, for example, brass and bronze. Copper is used extensively in construction, transportation, telecommunications, and manufacturing industries. Its versatility and wide range of properties makes it indispensable in many industrial processes. Copper is beneficial for your health. It makes energy, connective tissues, and blood vessels. Copper helps maintain the nervous and immune systems and activates genes. Copper is also great for brain development.
Copper is a metal that is all around us, quietly playing a crucial role in our lives. Firstly, copper is a key source inside renewable energy. It powers solar panels, wind turbines, and electric vehicles. This is thanks to its ability to efficiently transmit power. Next, let's think about construction. Copper is used in roofs, gutters, and aesthetic appeal. This is because it's tough, rust resistant, and looks great. Did you know copper has a rich history in coins? While not as flashy as gold or silver, it's the backbone of many coins, including those in the US. But perhaps copper's biggest job is in electrical equipment. It's in your wiring, your motors, and countless machines. This is due to it being an excellent conductor of heat and electricity. Copper might not be as flashy as some metals, but its practicality and usefulness makes it an essential in many everyday items. Did you know that so far about 700 million metric tons of copper have been mined worldwide, and there are still vast reserves waiting to be tapped? An estimated 2.1 billion metric tons to be precise. With the known and undiscovered resources combined, we're looking at roughly 6.3 billion metric tons of copper just waiting beneath the surface of the earth. And when it comes to copper production, only one country stands out: Chile. Located in the desert, Chile extensive copper mines make up about 28 to 30% of the world's copper supply. Of all the copper still waiting to be mined, a staggering 65% is concentrated in just 5 countries: Chile, Australia, Peru, Mexico, and the United States.
So, for the current locations of copper, copper is found in Chile, Australia, Peru, Mexico, and the United States. Copper is generally associated with intrusive extrusive magmatism and tectonic activity on the western boundary of the South American plate. The areas of flat slab subduction and absence of volcanism are where majority of the copper deposits are located. Copper is also commonly formed along volcanic mountain chains, such as the Andes and Rocky Mountains, and commonly found in subduction and divergent zones. Copper comes from hot fluids, mostly composed of water, released by cooling magmas, which explains why copper is usually found in these areas. And certain types of copper deposits are found at these boundaries, are known to be associated with the magmatism caused by one plate driving or subducting beneath another. Looking at the future outlook of copper, the demand for copper is increasingly on the rise. However, it is becoming more and more difficult and expensive to mine. If you look on the right, the demand for copper is increasing. However, the production is decreasing. This is because new deposits are becoming harder to find. This is leading for there to be a potential for scarce copper supply. I hope y'all enjoyed our presentation about copper. Thank you for your time and attention.